This episode's very special guest is Cody Spooner, Principal Systems Engineer and IR Expert at Corelight. Cody, welcome. Thank you for joining us. Why don't you tell us a little bit about yourself and your background?
Sure, yeah, thanks for having me. I appreciate your time and your invitation to be here. My background started out in the services side, where I dove into incident response and threat hunting. And from there, that was a natural transformation into the sales side of the world. So a lot of that practitioner background I've kept with me.
No, it's great having you. Corelight's a great partner of ours, and we're just talking about some great wins we've done together. But in setting this interview up, you brought up a great topic that I'm really interested to dig into, which is really this concept of enablers versus behaviors of a compromise. And so kind of where I want to start is when most people think of threat hunting, they picture analysts looking for clear signs of malicious activity. How do you explain the difference between a behavior of a compromise and the underlying enablers of a compromise that often go unnoticed?
Sure. So there's a couple pieces to that. So to break it down in a non-technical way first, let's imagine you drove to the store in your car and we're silly. We left our car keys in the car. It's unlocked. We go into the store to buy our groceries, right? The fact that you left your car keys in the car, that's not bad. We were just forgetful. It doesn't mean anything bad's going to happen. It's not malicious. But a car thief is in the parking lot and that person notices the car is unlocked. Well, now their job is easier. They're in the unlocked car, the car key's there, they can start it, they can drive away, right? They conducted a malicious activity because they were enabled to do so by something else, right? And that's the same thing that translates over to the technical side, especially when we talk about networks, which are important to both of us here. Same concept applies, right? You can have a misconfiguration on the network that by itself isn't bad, right? There's no malicious activity, but it might lead to a threat actor being able to abuse that misconfiguration for nefarious purposes.
That's a great example. And the word I use and I've heard from police is crime of opportunity, right? So when you present it that easily for them with your keys in the car, it's hard to, but the malicious activity is still there. So organizations tend to focus heavily on detecting malicious behaviors like data exfiltration or unauthorized logins. Why do you think enabling conditions such as misconfigurations or legacy protocols often get overlooked?
Yeah, so we could go into a real deep philosophical answer with that, I'm sure, with the nuance of corporations. But I think it generally boils down to, all right, I'm an analyst, maybe I'm new at the company, maybe I've been here for 20 years, and I see Telnet on the wire, right? Something that's outdated, shouldn't exist anymore, but it's there, and it's there because it's always been there, right? So we, as threat hunters, responders, are trained to look for the anomalous, what stands out against the norm. Well, if that baseline norm is enablers of compromise, we start to ignore them simply because it's always been that way. And whether that's right or wrong, I think we start to see a lot of things that are difficult to change in an organization. It's certainly not easy trying to convince IT to make a change that might impact a bunch of stuff. But that doesn't mean we should forget it, if that makes sense, right? Like, Telnet's a great example. Like, we should say, hey, this still exists. Why does it still exist? Every org does their own risk assessment and all of that stuff, but we got to continuously challenge it, and I think that's where it starts to slip through the cracks.
Yeah, no, that's a great example because most companies implement SSH to log into things now, so clearly it's a perfect example. We've seen together at some of these big events that we've worked together, Corelight and Endace, clear text authentication being a problem at trade shows and things. And it's a classic example of non-malicious enabler that can be exploited. Can you kind of walk us through a scenario where a harmless misconfiguration or configuration becomes the doorway to a full compromise?
Yeah, absolutely. So there's a few elements here. One is just human behavior. We tend to be pretty repetitive in what we do. That means password reuse, and a lot of times, right? So if you have let's say a web server that isn't using a valid SSL certificate, and you authenticate to that, there's a good chance that maybe you're reusing that password elsewhere, whether that's your Active Directory account, log into your Git repository, whatever it is. Threat actors will abuse that. If it's in the clear and it traverses the network, we have great solutions that are going to identify that. We're not the only ones that are going to identify that. A threat actor can sniff that as well. Right. And if they sniff it, they can use it against you. So whether it's a web server, your LDAP traffic to Active Directory, all of those credentials are fair play for a threat actor to take and try to grow their presence in the network during a compromise.
No, it's a great example. On that note, you mentioned Telnet earlier, and I think that's a perfect example as well. How do you outdated and deprecated protocols like NTLM v1 or SMB v1 that often continue to persist in some modern environments? What risks do they introduce for incident responders and threat hunters as you're trying to investigate an issue?
Yeah, I think risk turns into a bigger word here. From a response perspective, if we see clear text stuff, whether it's Telnet, web servers, whatever, I think the next question that follows up is, okay, was this used to facilitate further compromise, right? I think that's pretty dependent on what the chain of attack is going to be. However, I think it also becomes very interesting when we dive into, hey, we can see the telnet. Oh, that telnet goes to a Cisco switch that everybody forgot about. And, you can pull the full configuration out of it, right? Because it's old, it's antiquated, and it's just forgotten. Threat actors love to use that as much as we love to identify it.
Yeah.
So does that kind of answer the question there?
No, it does. And your example fits perfectly because, you get to that old switch and then you have routing configurations and other IPs of key devices, DNS servers, things like that within your infrastructure. And you begin to open Pandora's box of what you can get access to, right? So that's a good example.
Go
ahead.
Sorry. Yeah, it also becomes interesting, not just from the response side, but if we take a proactive approach from a threat hunting side to try to identify things before they're a problem. It's really interesting to go to companies and challenge kind of what their business stance is. If we go to a company and say, hey, when was the last time you did a tech refresh on your core networking stack? A lot of them will say, oh yeah, we've done that in the last 5 years, right? But then we'll go look at the network traffic and we can see, oh, well, why is this newer switch using Telnet for access to, right? And then it turns out, oh, that stack was forgotten about. So from a proactive side as well, we're able to start identifying those things and start challenging, hey, your expectation was this didn't exist. The packets don't lie. It's right here.
Yeah, no, absolutely. So from your experience, and I know you've got a lot of perspective on this, what's harder, detecting behaviors of active compromise or identifying those quiet misconfigurations and structural weaknesses that really enable them, and why?
Yeah, so this will turn into my personal opinion, but I think it's easier to identify misconfigurations because they're more prevalent. Right, the likelihood that there's an active compromise is significantly lower than the likelihood that there's something misconfigured on a massive network of a Fortune 500 company, right? There's just, the scale is massive. So I think from that perspective, you will identify more misconfigurations on the network than nefarious threat actors. But with that said, I think more tends to happen with a threat actor involved than with the mundane, this traffic exists because it's always been that way, right? It's easier to actually do something with that information, and I think we see it more commonly, something done with that information when there is a threat actor involved.
No, that's a great point. And you're right. And the other comment you had there was the size of some of these environments, right? It's just so easy for things to get out of date and kind of left unattended in some of these infrastructures. And that's even, from my perspective and our perspective, that's even compounding with some of the migrations to cloud workloads, right? Because they don't have full grasp of everything in the infrastructure in the cloud, and then they've got legacy systems they're not paying attention to because they're focused on the new stuff. So I think that's an excellent point. If you had to advise security teams on shifting their mindset, what practical steps should they take to better identify and prioritize enablers and not just behaviors in their threat hunting workflows?
Yeah, so when we get into both response and hunting, at the end of the day, it's all about asking and answering questions. So I think the shift needs to be in what questions we're asking. Not so much, hey, did somebody break into my car? But if somebody were to break into my car, how would they do it? Oh, well, the door was unlocked and the key was in there. That's important information to know because that might help us answer, did they break in?
Right. No, that's a great point. Don't leave the door open and wonder why somebody walked in, right?
Yeah, absolutely. So I think if we shift the questions we ask, it'll help us identify more of those enablers. And ideally, if we're asking those questions routinely, hopefully we keep those identifications or artifacts relevant in our day-to-day conversations.
Mm-hmm. No, that's a great point. So how do enablers influence the way IR teams should interpret and contextualize those indicators? To your example of if the car was unlocked. But in other words, how does the why behind an attack change the response strategy?
Sure. So every response strategy is going to be a little bit different. Every customer, every company has a different break glass scenario. I think the artifacts start to steer that quite a bit. For example, when we see something like NTLM version 1 on the network, well, the abilities that attacker had to gain credentials and laterally move have opened up, right? That door has opened up a little bit. So there's more avenues we need to explore there, things like pass the hash, for example, where if you're using, I don't want to say more secure, but maybe more modern protocols, updated versions of those protocols that are encrypting things, and where the skeletons are in terms of misconfigurations, you can see how wide that door is open. If everything's encrypted and hey, they probably couldn't do this technique in our environment, then we're going to change the question to look elsewhere, right? Maybe it wasn't pass the hash, maybe it was some other exploit or technique they used to gain credentials, whether it be phishing, some exploit, etc.
Right. No, that's a good point. Is there any sort of interpretation, kind of following on to that, is there any sort of interpretation of what the end goal might be based on if they got in with an enabler versus brute forced it way in? I guess this
kind of goes back to crime of opportunity, right? If you are spreading ransomware in an environment, your goal is to inflict damage. Now, we see a lot with things like ransomware with extortion and stealing data. Well, if you left the door open and they have an easy way to get that data, okay, maybe this is an extortion plus ransomware case. So I think it comes down to what that misconfiguration is, what that open door is, to try to figure out, okay, maybe they didn't steal this, but could they have stolen it? And if they could steal it, why wouldn't they? Right? Does that kind of make sense?
It does. It does. And I think that's the hard part for incident response and threat hunting teams is figuring out when enough is enough, or when you think you've rooted out the whole issue, I guess is a better way to put it.
Yeah. Go
ahead.
Oh, from a response perspective, it's very, very rare that we find the start and the end of a compromise like so cleanly. Typically, we find something in the middle that causes some form of alarm. We have to work backwards and forwards to figure out what that timeline is. Identifying those enablers can certainly help figure out what that timeline might have been, especially in the early stages.
No, that's a great point. The last individual I interviewed was really big on the timelining of an incident response. So that was a key point there too. So that's the second time I've heard that here just recently.
Nice.
Cody, asking you to kind of look ahead. I always like my guests to give me a prognostication, shall we say. What emerging technologies or architectural trends do you think will create new classes of enablers that defenders need to really start paying attention to now?
Sure. I mean, if we play some buzzword bingo here, we can just rattle off AI and cloud really quick. Those are definitely both very prevalent. I think AI being the newest of our buzzword bingo game. Cloud certainly existing. It's, everyone's had a shift to cloud for the last 5 years, and I don't think we've seen that slow down. Um, there's a couple of pieces there. With the cloud side, we're still seeing quite a bit of misconfigurations in terms of, hey, I threw this thing in Cloud X and it must be secure, right? Because I can connect to it, everything's fine. But we're seeing a lot of things, for example, HTTPS port 443. We see a lot of connections at the various conferences, both Endace and Corelight support together. Where those connections are intended to be encrypted, we can see that because they use the standard port for HTTPS, but it's all clear text, right? As in they didn't finish configuring it. So we see a lot of that in cloud, especially with API calls. That's pretty prevalent. We see a lot of applications on phones reaching back to cloud that are at least partially in the clear. So that's been pretty interesting. I think AI is a phenomenal tool. I'd be lying if I said, our technology isn't exploring AI, just like every other technology out there is right now. With that said, I think AI has also created a new era of misconfigurations. We see a lot more people building stuff with AI without necessarily understanding what they're building and then just publishing it, right? Which then feeds the cloud problem of we're deploying things not fully configured. So that was a really roundabout way of saying I think the enablers are probably growing more than reducing.
No, I completely agree with you. And the AI front's a multi-level complexity because not only is it opening up some of those doors you talked about, but it's sharing data, right? Part of the value of AI is in questions and data you share with an engine, that now becomes public domain or potentially, depending on which AI platform you're using. And I think a lot of people haven't fully grasped that yet and the ramifications of that. So that's an excellent point. Cody, thank you for taking time. I know you're super busy. Certainly appreciate your expertise and sharing your insights in how to better secure networks. We'd ask our listeners to tune in next time for another edition of the Endace Packet Forensic Files. For more information about Endace's network packet capture platform and our integrations with our fusion technology partners like Corelight, please go to endace.com. Again, Cody, thanks for taking the time. Really appreciate it.
Thank you.